guys, and welcome to this new video. Today I want to finally introduce you to the OpenEPaperLink project. This project is meant to replace the firmware on such e-paper price tags that are maybe discarded and not used anymore. In general, you can think of it like you have an ESP32 which is connected to one display as an access point, and it can control multiple different other displays you have laying around.
And as a fun side note, this project was used in a slightly modified version at the Hackaday Berlin 2023 event, where 300 displays were used to broadcast the event schedule across all the floor. And here you can see it even running on the table where 300 displays are refreshing in about 20 seconds. This worked very well at the event.
In some of my last videos I showed how to use such an CC2531 Zigbee USB stick to drive such displays with a custom firmware. But this is quite bound to your PC and you need to have some server running with the Python script. And this new solution is now using just the ESP32, which is running fully on its own and can make your life nicer by having such displays around your home. This video should give you a very minimal startup guide on how to flash the display, how to flash the ESP32, how to create the access point and what you can do in the end with it. Overall, this project is really brought forward by Jelmer, Nick and Jonas. I'm just sharing it here. Big thanks to these guys and yeah, everyone who's contributing to it as well, of course. Right now, this project supports the ZBS243 SoCs inside of these price tags. It may happen that in the future more chips are supported, more different price tags. Please check out the Github repo or OpenEPaperLink.de for infos in the future if more devices are supported, as this is just the status right now I'm sharing. This video will be split into a few different sections. For one, I will show you what is possible with it. So what will you gain from it? Then I will show how to flash such a display itself as just a client, I would say. Then how to flash or connect the ESP32 to it to use it as an access point. How to flash the ESP32. And at last step, how to get it running and how to upload a first image to such a display. Here we can now see the most minimal but fully running setup. We have for once the ESP32 as access point with one segment e-paper price tag and multiple different displays running the custom firmware. You can see it even updating right now to a new image. And inside of this access point are just three components. For once a segment e-paper price tag, but this could be any kind of these price tags. It just needs to run this ZBS243 SoC. The ESP32 is needed to have PS RAM, so it's enough RAM available to render the images. And this Flex PCB by Jelmer makes the soldering quite easy and also the case possible to be that thin. So if we take a look inside, it's really just these three components and this neat small case. And overall, if we now reboot the access point, the ESP32, the segment display is used also as a status as update display. And if the ESP is fully installed and running and joining your network, your Wi-Fi network, it will even tell you the IP address of it. So by rebooting it, we see it clearing, and after it has joined your Wi-Fi, it will show the IP address of it. So it's simple to enter the correct one into your browser, and you will end up with this status display. You can see that we have quite a few displays around. And you also see which one is waiting to be uploading a new image and what is the battery status, what is the reception and such. You can also see this first display here is the access point itself. If we would not use a segment display and such a matrix display, we could even use it as an additional display to display custom stuff. We also see that now we have some logging, and we can also do some access point configurations, as it's also possible to have multiple access points around the home, and each will just make the range further, and it's possible that way to have a broad reception over your home. It's also possible to enter the edit page, where you can directly upload images, like here, or just see the status and upload firmwares and so on. If we now want to upload a new image, let's say for example to the to this 1.54 and to the 2.9 inch one, which is currently just showing the date, we can click on the display and it will give us a few options to choose from. These are implemented already. Maybe there will be more in the future, but I will just show how to upload a static image on the display. And if we now just enter the a.jpg, it will just have a pending image now, and I will also write it to the other display, which maybe was the wrong one, but let's just exchange it to the B image. So the A image is for the 1.5 inch and the B image was for the 2.9 inch. And now we should just wait, and I will skip it forward for you so you don't have to wait that long. So we can see that both displays did their check-in and downloaded the new image. And these are both now JPEG images, and we can see that the access point has now no pending images anymore. Jonas did even add an Home Assistant plugin, so you can write new content onto the displays directly from Home Assistant and even get the status of each display, like temperature and battery data. That's it for the show off. It's quite simple to get everything up and running and to use it as well. So let's continue with the flashing. While this now looks quite like a mess, it's the best to show it that way. So the flashing of such a display can work with basically any Arduino microcontroller. Like here a normal ESP32, the ESP32S2, the S3 and so on. And also the connection can be done in multiple ways. So like here with the so-called Pogo flasher, with this jig where you can insert the display and flash it without any soldering, or by directly soldering to the pins of the display and flashing it that way. There's even this dedicated PCB which works as an access point and additional as a flasher all in one. This is also by Yelma and you can find it on GitHub as well. The most important part is basically just that you need to solder your ESP32 or any other Arduino microcontroller to the correct pinout of the display. You can find on the ZBS Flasher GitHub repository the pinout of multiple different display versions, and also in the code of the ZBS Flasher you can find the pinout you need to use, or you can even change it in code. In the future there will most likely be even a version where you can use the ESP32S2 as a dedicated flasher and access point in one. But right now I will just link down in the description the video where I show you step by step how to flash such a display via this Pogo flasher and how to get the ZBS flasher software running on your PC. It's just important that you choose the correct firmware file from the OpenEPaperLink repository for your display you want to use, like the 4.2 inch one or the 1.5 inch or the 2.9 inch version. Here's how the flashing itself looks like. We have inserted one display with the original firmware. Insert it in your flasher, however this looks like and what jig it is. We have a folder now with the binary file of OpenEPaperLink for the 2.9 inch and also the ZBS flasher in it. So if we go into that folder, that way we can choose the ZBS flasher. It is possible to supply a COM port, but we will not do it, and it should automatically detect the correct ESP32. And we want to copy the MAC that the original firmware is using into the info page, so we don't need to select an own MAC address. We could also select an own MAC by doing this and now entering the 16 characters, which need to be the first 4 0, and then you can choose whatever you want. But if you just supply the MAC, it will automatically copy it from the original firmware into the info page. You need to look out, as this is only possible once, as of course if the new firmware is flashed, there is nothing to copy the MAC address from. Then we want to write, and we want to write the tag firmware. If I now press enter, it will search for the correct COM port. It will copy the MAC address and will flash, of course, the firmware itself to the display. After this is done, the firmware is correctly flashed. We can take out the display, insert the 2 batteries again, and the display should boot up in a moment. And if not, as we may see here right now, it is best to short out the battery contacts, and I'm doing it mostly by just placing in the battery the wrong way, hammering it on the table to get it out again, and then inserting it back again. And as you can see, this worked. The firmware is now booting and searching for an access point. To make it simple enough, the hardware connection of the ePaper display and the ESP32 is really just the same as while flashing such a display with a custom firmware. Only that we now need to also supply the UART connection from the display to the ESP32, as this is where the OpenEPaperLink data protocol is running. You can find the platform io.ini file in the OpenEPaperLink GitHub repository, and there you can also see the pinout for each different variant. So for the S2 or the S3 version, and you can even or could even change the pinout to your needs if you have a different hardware connection. I will continue by using the Flex PCB and solder up one segment display to the ESP32 and show how to continue from there. But you can see that this is really just a hardware connection, which you could also do via such a silicon wire or some emaled copper wire, the same way as now with the Flex PCB, just that it is way simpler. And also here you can choose the matrix versions or the segment version. To solder it up, I will open the segment display. You can do it by just prying it apart, getting the PCB itself out, and also pulling away this battery contact, but a bit careful to not destroy too much of the PCB. And now these parts are already finished. The next part is to solder on the T10 connections to the PCB of the segment display, aligning it perfectly, and then to solder up the ESP32 to the other side. And that's basically it. So to align it, I'm really just putting it above each other and starting at the part where my finger is, having the solder on one hand together with the PCBs, holding it above each other, and yeah, just heating up just a little bit of the PCB. You need to be careful to not hold it too long there, as the flex PCB is of course just not that heat resistant as a normal PCB. And with a bit of soldering, all 10 connections are done. You may wonder what this other part is for. There is a CC2651 module that could fit here exactly on to use that as an at the RF interface later, but it's just to choose from. It's not needed if you have an ZBS243 SoC installed. So the next part is then to solder on the ESP32. To do that, I will also hold the PCB, the flex PCB, onto the ESP32 PCB and align it like so, holding it together with 2 fingers and getting the solder onto it as well. Like so. And now I want to heat it up the same way. Like that. And normally you would only need to solder the correct pins, but I will just solder each one so it looks nicer and is a bit more sturdy. So like that. And now it's also a bit simpler to hold, since the position is fixed already and we can just press it together. On the other corners. It seems to not be perfectly aligned, but it is enough. So now I'm continuing to solder each pin. So like this, we have each pin soldered on. This is basically it, or everything hardware related. And the next step is to flash the access point firmware on the ESP32, connect it to your Wi-Fi, and then just start adding the displays to it. To get the access point now fully flashed, we want to access the OpenEPaperLink.de page or directly the GitHub repository and download the whole repository as a zip file. And we could just reload it there. And after the download is finished, we can close it and extract the zip file and go into the folder. What we now need to do is once copy the so-called AP pack into the data folder of the ESP32 AP flasher. As when downloading the zip file, the bin file is not replaced automatically by it. This way, if it's now replaced, it's simpler later. What's next to do is opening up Visual Studio Code and adding this ESP32 AP flasher as a new workspace into it, after it has fully boot up, like so. And the rest is now happening inside of it. We need to wait a little bit until Platform IO has successfully load everything inside. So the loading is now done. And we can see that the Platform IO INI has multiple different variants inside of it, like the Mini AP, the AP and Flasher, which is the bigger PCB. And we need to select now the Mini AP, as this is the ESP32S2 with the segment display, or any other one. And looks like I need to install Git client for this PC first as well, which I will do right now. Git is successfully installed. I will restart Visual Studio Code with Platform IO, and it's now loading the project better inside of it. This did take a few minutes now, but since it's downloading all the necessary libraries and ESP32 tools and everything automatically, it's also quite neat. The speed will of course depend on your internet and PC speed. So what we basically want to do now is connect the ESP32 by plugging it in and bringing it into download mode. As this is the first time it's booted and has nothing on it, we need to get it into hardware USB mode. We can do this by holding the reset button, pushing the 0 button and leaving the reset button. We heard already that the PC was recognizing it, and it's now in this download mode from the internal ROM bootloader. We can basically now click on upload, either by this button or go into the Platform IO section and go there to the upload. And so I will do this now. This will also take a few minutes now, but let's see. So after the firmware was successfully compiled, it will now try to upload it. And this can sometimes fail, as the ESP32S2 has this download mode and it sometimes does not enter it correctly. But let's see how it works. And it's also worth to mention that we can define an upload port and monitor port in the platform.io.ini in case you have a normal ESP32. We can now see that the upload is working. It has successfully detected the correct port. And after it has 100%, we will then do one more upload. So it's now saying that it has failed, but this is just because we brought the ESP32S2 into this download mode via the button. It cannot exit it via software. We need to reset the chip by hand. After a reboot of Visual Studio Code, we now can also see the missing part I was searching for. And what we want to do is now also upload the file system image. This is basically all the files that are stored externally. One part is the firmware and one part is like a USB drive where you can have the images and the website and such. For that I will just reboot again the ESP32S2 by holding reset and the 0 button, releasing reset but still holding the 0 button, and now it was rebooted into the bootloader mode, and I will hit upload file system image. This will now create this extra partition and should upload it in a moment. We can see the upload is now nearly done. It is erroring again as we need to manually reset the ESP32. And basically that's it from the flashing side of the ESP32. If we now reset the ESP32, it will boot into the new firmware. And we want to directly also open the serial monitor to see just basically what it is doing internally. We can see that the LED is already flashing like it should. The display of the ePaper display is not showing anything right now. We now need to configure the ESP32 so it will enter our Wi-Fi. So we need to configure it. On it is running the Wi-Fi manager, which will open up an access point. And we should see this Auto Connect AP now. And if we connect to it, it should open up this captive portal and we can now configure the Wi-Fi of it. It will show all the available networks around. I will enter my data and it will now reboot, and we can see here in the log that it's now rebooting and it has got an IP address from the server. We can now see that after the first real boot, the ESP32 is trying to flash the display, and we can see it has successfully detected the segment display and is flashing the correct firmware to it. We now need to power cycle the access point and the ESP32 as well, as this solution does not have any power control over the ZBS microcontroller, and that needs to be rebooted after it is flashed. So I will close the terminal first, unplug the ESP32, plug it in again, and also directly go to the terminal back again. And we now can see that it is booting correctly, it's showing the IP address. And if we now enter this IP address into the browser, we can see it has successfully booted. It has again one display, which is the access point display itself, which we now cannot use as it's this segment one. This is everything for the flashing part. The access point is now successfully running as it should. We could close the UART terminal, we could close Visual Studio Code and do the rest just via the browser, as this is now everything needed. We could even power the ESP32 by a wall plug and plugging it in somewhere we want. To now connect the displays to the access point, we simply just reboot them, which again the old battery trick will do. So just putting them in the wrong side, plugging it in again. Same for the small one. It will again scan for an access point, which is then showing up for once in the browser and also of course in the ePaper display of the access point. We can see now both, or the small one is still connecting to it, but both are waiting for data, so they are successfully bound to the access point. They have found it, and we can see that both displays are now automatically added in the browser in the ESP32, and we can just, for example, for the 2.9 inch, just put in a counting hours mode. We can see that the access point is now pending one image. You can see the one. And for the small one, let's just enter a very simple image again. We can do it by going to the edit page. The login is admin and admin. We select an image I created, which is called a.jpg again. It will be uploaded like so into the web space, and it's now laying on the ESP32 directly. If we now change the static image to the a.jpg and click on save, we just have to wait until the small display is requesting again, is waking up again to request any new data and to download that. And the big one has already downloaded it in background, as we can see. And it's now counting up automatically every hour. Everything is done inside of the ESP32 and the display just requests the image. And the same for the small one. Depending on the content we set, it will do different parts, of course. So after now a bit more waiting, the small display has now done its check-in and has downloaded the newest image and is showing it now. And you can see that it's the JPEG file I selected it to be. Overall, you can now use the different topics you want to use here, and just like also the Home Assistant plugin. It's overall quite simple and a nice overview. So that's it already for the self-sufficient OpenEPaperLink project and on how to get started with just a few small parts. And make sure to check out Github, the OpenEPaperLink repo, and also in the future it will maybe be made compatible also to the 7.4 inch. So this ePaper wall can then also run on OpenEPaperLink. The only problem there is that maybe the RAM and memory is quite limited on the ESP32 and needs some additional server again to hold back all these images. Okay, see you next time.